Hi guys, the last time on 8.2 we talked about like the rest of the inverse trig functions among like the six trig functions. So just a little bit of review for that before we jump to 8.3. If there's anything on 8.1 and 8.2 you guys have to remember, I will say that it's about like the range of the inverse function, right? So I always told you guys the trick with them would be like we're not gonna ever have question 3, so 3 is like out the way. For sine inverse, tangent inverse, and cosecant inverse, we're gonna have either on question 1 or question 4, and then we just put either sine inverse and its reciprocal also, which is like cosecant inverse and then tangent inverse, right? And they have to be from like negative 90 to like 90 strictly, right? It cannot be bigger than 90, it cannot be smaller than negative 90, okay? And then as for the other three, it has to be either on the first question or on the second question in terms of, being from 0 to pi or like 180. And they are cosine inverse is reciprocal, which is like cosecant inverse. And then lastly, we also have like cotangent inverse, okay? So that's all of like the things that I want you to remember. And from before, make sure you remember the table or like the quadrant of all students take calculus for like the original six trig functions: sine, cosine, tangent, cosecant, secant, and cotangent. Okay, make sure you know how to use them and make sure you know the difference between the inverse and the original function. Okay. Now let's talk about 8.3 trig functions. Okay, so just some definition there. A trig function is the equation involving trig functions, right? Like equation, function, like pretty much the same thing. That are satisfied only by some values of the variable, or possibly are not satisfied by any values for of the variable. Okay, so the solution could be more than one. It could be one, or it could be none. Okay, so just keep in mind that like the solution can like you can have the case of the solution doesn't exist. Okay, and that's okay in like this like trig class. Okay, and the solution of the equation are the values that satisfy the equation. And what does it mean by satisfy? Okay, I'm going to show you guys like one quick example to show you guys about that. So by the first example in here, the first question in here is that circle the angles that are all solution to the equation this. I have like redden all the answers in here and put them in red. And if you want, you can check them also. In place of like theta, you can plug in 0 first. And if you plug in 0 to the theta in here on the left hand side, you're gonna get 2 times cosine of 0 plus 4. And make sure if you have like degrees, you're gonna put it in degrees. And if you have like gradient, you're gonna put it in gradient mode. Okay, so this is something about your mode in the calculator. Okay, so for 0, for like part A in here, well, as you can see, there's no degrees, right? So it means that it's not a degree. It has to be in radian. So let me put it my calculator in radian first. And then I'm going to do 2 cosine 0 close parenthesis plus 4. Okay, and that gives me 6. 6 is not 5. We need a 5, not a 6, right? So then that's why this is not the final answer. I mean, this is not like one of the answers, okay? And next up, if you plug in like negative 60 degrees onto this equation, and because it's in degree, make sure your calculator is also in degree mode. And you're going to put in like negative 60 in there, and I'm going to get a 5, right? Which is exactly what I have on the right side here. So this is like one of the like answers that I have. And if you keep doing that for C, D, E, F, G, H, I, J, you're gonna have like all the answers in red in here, and the like the things that in black in here, they are not the answers. Okay, and in terms of like the answers, we're gonna call it official by solutions. Okay, in math terms, answers are solutions. Okay, and satisfy in here, it means that it's matching with like whatever you have on the outer side of the equation. Okay, so conclusion, just like I said before, we can have no angle, one angle, or more than one angle as for the solution or for the answer, depending on the restriction of the domain that the problem gives us. Okay, and if you don't want to, like using like guessing like technique to solve for like the answer in here, just imagine cosine of x, I mean cosine of theta is an x in here, then you're gonna get this equation, right? And then how do you get the x in there, right? Well, first of all, you're gonna get a way. You're gonna find a way to get rid of the 4, and after that, you have to get rid of the 2, right? So fast forward, we're gonna like minus 4 from both sides, and we having like 2x equals to 1, and after that divide both sides by 2, and we having x equal to 1/2, right? So I'm gonna write 1/2 in here really quick, and just to link this with the example that we have earlier, x in here is actually cosine of theta, right? And just like what we learned from 8.1 and 8.2, if cosine of theta equals to 1.2, what is theta, right? Like what is the angle, right? So there's a lot of ways to do it. Graphically, you can graph the graph of cosine of x or cosine of theta, either way that you want to do it. And then on the y-axis, you have to find a value of like 1/2. Like this is 1, right? So then half of it in here, you're gonna get 1/2. And you draw a horizontal line there, and it passes, it like touches the curve twice in here and in here. Then you're gonna have two value of 60 degrees and also negative 60 degrees, right? So negative 60 and 60, they're original, like the two angles that we have. This one in here is like the reference angle or the coterminal angle of either the negative 60 or the 60, okay? Same goes for this one and this one. They are either the coterminal angles or the reference angle of the two, negative 60 or 60 degrees, okay? So as you can see, for like one function, we usually get like two values for them, right? So just keep in mind, because that fact will come around like later on, okay? And yeah, if you don't want to use it by the graph, again, like this one, I show you the table with like the 30, 45, and 60 degrees already, and you go by like, you know, like SOHCAHTOA in here, and you have to look for the value of 1/2 for like the cosine row in here. And if you notice in here, you're gonna have like 1/2 in here in terms of a cosine, and it's underneath of like 60, which is pi over 3, right? That's why the answer in here is like pi over 3. Okay, that's like another way to do it. Okay, if you don't want to, again, you can like swap them back into your calculator and input something like cosine inverse of 1/2, and it's gonna give you the value of pi over 3 also, which is like 60. Okay, so I'm showing you guys like 3 ways to do it. You can do it like this way by looking at the graph, or you can do it this way by using the calculator, or you can do it this way by looking at like the table that I usually like mention in the lectures. Okay, and now let's talk about the unit circle. Okay, I'm not gonna ask you guys to remember everything on the unit circle, because like I personally don't. I can like retract it from the unit circle to get all the information I want to. And again, if you want to know how, set up like a Zoom meeting with me. I can show you the trick, okay? But I like warn you first ahead of time that it's gonna be a little bit kind of like tedious, and it's a lot to, you know, like to do, but it's worth it. Like trust me, it's worth it comparing to, you know, like memorize like everything on a unit circle, right? Okay, so I'm giving you this page in here. It's like a support page. It helps you a lot to understand the next page. Okay, let's talk about the first diagram in here. Given a unit circle and a point P corresponding to the given angle. So this point here is P, right? And it corresponds to this arc in here for the angle. If like to make it easier, let me give you like a value for it, right? Let's just say like this arc in here is like, I don't know, like 60 degrees. Okay, so then what is the x coordinate of this point and what is y coordinate, right? Well, first of all, we know that the x part is for cosine of 60 and the y part here is for sine of 60, right? So if you use the table that I'm usually mentioning in the worksheet, you can like easily figure out that cosine of 60, it equals to 1/2, and the sine of 60 it equals to square root of 3/2, okay? If you don't want to do it this way, I can show you the other way. This is the way that I usually use to retract like all the information in the unit circle, okay? So what I'm gonna do is from the point here, I'm gonna project it down toward the x-axis, and if you like eyeball it, you can see right away that this point here is right in between 0 and 1, right? That means it must be like 1/2, okay? So then this is 1/2, okay? Like no question, okay? And among the table in here for the 60 family, you only have two options, either 1/2 or square root of 3/2 for x and y, okay? Because x in here is 1/2 already. That means that the y part is automatically becomes square root of 3/2, okay? if you remember from the table that I mentioned, usually in the lecture, you only have like three values for sine and cosine, right? You either have like 1 over 2, square root of 2 over 2, or square root of 3 over 2. But square root of 2 over 2 is usually used for the family of 45 degrees, right? And since 60 is a family of like the 30, that means we're not going to ever have square root of 2 over 2. And that's why you only have like two options of 1 over 2 or square root of 3 over 2, okay? That's why, like, if the x part looks like 1/2, then it must be 1/2, and the other one, it must be square root of 3 over 2. And in other cases, like if you project it down toward the x-axis and it doesn't look like something in between 1 and 0, that means your x part would be square root of 3 over 2, and then your y part would automatically become 1 over 2, okay? So again, just be like clear about this one. X in here will be for cosine value, and sine here would be for y value, okay? So now on to the next question in here. What is another angle that has the same cosine value as a p on the unit circle, right? So we're talking about like cosine here, right? So my trick in here is that we're gonna look across the x-axis because we're talking about cosine, and cosine represent x, right, in the xy coordinate. So from P, I'm gonna project it down like across the circle, passing through the x-axis. So I'm having the outer point here, right? So if this gap from here to here, if it's 60, then what is the arc from here all the way to the outer point here, right? Well, this one you can use geometry to know it. Well, first of all, you know that like this arc in here, let me put it in pink. By symmetry, it's also like 60, right? So we have like 360 in a circle. That means that the blue part, it has to be 360 minus 60, which is 300 degrees. Okay, and again, this one is just simply by using like geometry, right? Like you like connect all the arcs together, and then you like use reflection to get like whatever left over, okay? So now that we figure out the angle, let's try to figure out like the coordinate of this point, right? And I told you guys, like whatever you want to do, you always project it like up or down toward the x-axis. And this one looks like a half to me, right? Because it's right in between 0 and 1. So again, the x part, it would be a half. And automatically the y part will be square root of 3 over 2. Okay? But then remember one thing, on a unit circle, we never ever will have like any coordinates that look exactly like each other, right? If you know this point here and this point here look exactly like each other, which is like a weird thing, right? So what's wrong with this? Well, because the second point, the one in blue, is actually like in the fourth quadrant, right? In here, the x part would be positive, but then the y part, it has to be negative. And that is the minor difference between, you know, like the two green circles that I have in here for the two coordinates. Okay? The x part is the same. That means that they have the same cosine value, but then they will have like the opposite sine value, okay? P would be in positive, and then the outer angle, like the one in blue, it has to be negative in terms of like sine value, okay? We're gonna use the pretty much the same like technique for sine value to get the angle that has the same sine value in here. Well, we're gonna project the point through the y-axis, okay? So we're gonna go across the circle all the way, passing through the y-axis, okay? So just imagine that originally your arc is right here at 60, right? So now your arc is all the way to here, then how much is like that blue part, right? Okay, let me put this in pink. We know that like from the whole thing, from the first quadrant, is 90, right? So if the red part is 60, then the leftover of it must be 30 degrees, right? And then on top of that, by symmetry, we know that this part in here is also 30. So add everything up together, like on the calculator, you're gonna get 60 plus 30 plus another 30, which is 120. So this point right here, it is 120 degrees. Okay, and again, this is by, you know, like using the symmetry in the and the geometry in the picture, in the circle, okay? And again, like if you don't want to do it this way, here, let me show you another way to do this. Let me start all over. This is like the second technique to figure out the angle in here. So again, we start up with, you know, like an arc of 60 in here. It's given by the problem, like by here, right? I want to know how much this arc is, right? But then on top of that, I know for the fact that this whole arc in here, the pink arc, is actually like 180, right? So to figure out like the blue arc in here, what I'm gonna do is that I'm gonna figure out the green arc in here first, and I'm gonna take the pink arc minus the green part, the green arc, and that will give me the blue arc. Okay, and the green arc in here by symmetry again is also like 60. So then this is 60, right? So we're gonna do like 180 minus 60, and this will give us 120. That's why we end up with the same answer as before. This point here, it is 120. Okay, and again, let's talk about the coordinate in here, right? So I always told you guys, let's project it down to the x-axis. To me, it looks like a half, right? Because it's like in between 0 and -1, but watch out for the -1, right? Because it's in like -1. So your answer in here, it must be like -half. It cannot be like a half anymore, because we're talking about the left hand side of the x-axis right now, right? So the coordinate in here, it will have like -1/2 in here for the x part, and for the y part, it's automatically becomes square root of 3/2. But then we have to watch out for the side of the square root of 3/2, right? On this point here, the y part is on the like top part of the y-axis. That's why it's positive, right? So this is it. We're just gonna keep it as positive square root of 3/2. Okay. And if you look at it, the original point, if you want to compare like this coordinate in here to the original like coordinate of the p in here, as you notice, the side part is the same. It's just like square of 3/2 and square root of 3/2, right? But the cosine part, they have different signs. They are different, okay? And lastly, I'm gonna show you guys how to get the tangent, okay? So just like the same idea that we did in like 8.1, we're gonna use the idea of the period of tangent, because the period of tangent is like pi. We're gonna look through the origin, like we like go across the circle like 180 degrees. So let me circle. This technique is that for tangent, we're gonna go through the origin. So we have a point there at the beginning, right? And then we shoot it through the origin all the way to the outer side of the unit circle, and we end up having this point here. Okay, and again, you're gonna ask me like, what is the angle of this one, right? So originally we know that this angle in here is like 60, right? So how much is it for this blue arc in here? Okay, there's a lot of ways to do this one, okay? By geometry, I will say that, well, this arc in here, let me put in pink. This arc in here is also 60, just like the red arc that we had from the beginning, right? And then like this piece from here to here is half of the circle, which is like 180. So together, if you put it into the calculator, 180 plus 60, we're gonna get 240, okay? So the blue arc right here, it is 240 degrees. Okay, and again, let's talk about the coordinate that we have in here. So what do we have? Well, if we look, if we project it up to the x-axis, it looks like a half, but then it's on the left hand side, so it's -half. And automatically, the other one becomes square root of 3/2, but because we in the third quadrant, and in here, the x and the y coordinate, they both have to be negative, right? Because in third quadrant, you know, it has to be on the down side of y-axis, and it has to be on the left-hand side of the x-axis. That's why we're gonna have like them both being negative, okay? And last step, if you compare it to what we have originally for p, you can see that none of the x or y are the same, right? That means that cosine values in here are different and sine values are different also. But if you divide them, right, like we know that tangent equals to sine divided by cosine, right? So we're gonna take the y part divided by the x part, we're gonna get the same answer, okay? Because this in here divided by this in here is the same as this in here divided by this in here. Because like the negatives in here and in here, they will cancel out with each other, right? So at the end of the day, you're gonna get the same tangent values, okay? So if there's anything that you have to remember from this like picture in there, to find like the same cosine value, put it through the x-axis. To find the same sine value, make it through the x-axis, and to get the same tangent value, make it through the origin, okay? As for like secant, cosecant, and cotangent, we're not familiar with it, so my best advice would be like whenever you have like secant, cosecant, or cotangent, flip them back to cosine, sine, and tangent, just so it's easier for us to deal with, okay? So now let's talk about the first objective of the day. Solve equations involving a single trig function. Okay, tips again. For a shortcut, I would prefer drawing out a unit circle and use geometry within that unit circle to get the general formulas for each brand of the angle. Okay, so as you can see before, like on the last page, for one value, we usually get like two angles, right? Like we usually get like one positive original angle and the other one would be, you know, like either through the x-axis, y-axis, or the origin, okay? That means that we have two families of angles in there, okay? So keep in mind that you should get at least two answers, okay? Well, for some like extreme case, like the four quadrantal angles, sometimes you're just gonna end up having like one value for the trig function, but most of the time it is not about like the four quadrantal angles. You usually end up with at least two answers, okay? Like two family angles, okay? And lastly, there's a difference between solve the equation versus solve the equation on the interval, okay? So what I mean is that this one in here would make a big difference, okay? Like if I restrict it to like one interval, it means that you can only get the solution within one cycle, okay? Like one cycle from 0 to 2 pi. You cannot repeat the graph. You cannot extend it to, you know, like bigger than 2 pi or like less than 0, even though the graph in here is periodic and you can extend the graph on two sides of, you know, the function. You cannot do that if I restrict the domain already, okay? So watch out for that. To get a better view of what I'm talking about, let's do the first example in here. Solve the following linear trig functions. Okay, so what do we do here? Well, first step, solve for the trig function, okay? It means that we have to solve for tangent of theta in here, okay? Treat it like an x if you want to, okay? So how can we solve for it in here? Well, we have to get rid of the 2 and then we have to get rid of the 3, right? So with that said, I'm going to go ahead and minus 2 from both sides, and I'm going to get something like 3 tangent of theta equals to negative 3 in here. I'm going to go ahead and divide everything by 3 and end up having tangent of 3 equals to negative 1, okay? Now let's draw it out, right? Just like what I recommended you guys earlier. Draw it out. We have a unit circle in here. So tangent of what angle give you negative 1, right? If you remember from the chart I give you with like the 30, 45, and 60 in there, we have like SOHCAHTOA, right? And then if you remember, like the only thing that has 1 in here for the tangent would be 45. The 1 will stay right there, right? And the negative in here is for like odd functions. So if you want, you can think of it like negative 45 degrees to change for the value of negative 1, okay? So my angle, my very first angle in here would be negative 45. And it should be like right here. Let me put an X onto it for like negative 45. And I told you guys there would be like two family, right? So to get the outer family in here, we're gonna look across from the origin all the way to the unit circle, because we talk about tangent, right? And tangent here, it means that we have to go through the origin. So toward the other side of the unit circle and have that angle, right? So what is this angle right here, right? So I'm gonna use geometry again for this one, like I recommend. So this arc in here is like 90, right? And by symmetry, this arc in here is like 45 degrees. So if you add them all together in the calculator, you're gonna get this one equals to 135. Okay, let me keep it in ping, I guess. 135. Okay, so this is one family and this is like the other family. Okay, and I personally like to keep everything like positive, so I'm gonna write this one as a positive angle. So negative 45 is the same thing as, what is it, 360 minus 45, 315, okay? And as for the reasoning, they are the coterminal angle of each other. If you don't remember the coterminal angles, please look back in the previous notes to figure that out, okay? So we're having two families in here, right? This one right here and this one in here, okay? How can we put them as the final answer, right? So we're gonna write theta in here equals to this one in here, if you want to put it into, you know, like the what is it, the radian notation, because like chances are you have to deal with radians like from now on, like all the way to the end of the semester, so you have to know how to convert it, right? So this is 3 pi over 4, and the other one is 7 pi over 4. We're having two families, and we're going to put them down as two families in here. 3 pi over 4 plus 2k pi and 7 pi over 4 plus 2k pi. Okay, as for the reasoning why I have to include the part with like 2k pi in here, okay, think of it like this. If you don't want to get the angle of like 135 right here, you can actually go for another circle, right? So just keep adding it to like 360. You're gonna get like more points. They actually like the same thing. You stopping at the same place, right? But more names in there. So if you want to get like more like angles in there, you can definitely do that. That's why I attached like this plus 2k pi in there. Okay. Same goes for the other one. Just imagine if you can go back and forth for more circles, you're gonna get like more points, right? One position, which is more and more points. That's why I keep attaching like the 2k pi in there. What's the meaning of it? If you think about it, 2k pi, if you want, you can rewrite it as 2 pi and then k, right? It means that you keep making like more circle. Okay, like if k is 1 in here, you have one circle. If k is 2 in here, you have two circles. And if k is 3 in here, you have like 3 circles. And keep going on and on and on and on, right? And then it doesn't limit you to like the negative numbers, right? It doesn't like limit you to like the outer way of rotation. If you want to, you can go backward by plugging k as -1. You're gonna have like a negative angle in there. If you don't want to, you're gonna go back like 2 times, 2 circles, and then it's gonna give you some like bigger negative angle. But again, more points, more names, one position. Okay? So this is the final answer that I want you guys to show me on the quiz and on test. Okay? And what is k in here? I forgot to tell you guys. K in here, as you can see, k in here is actually the integer. So make sure on the test you guys will tell me that k is the integer, okay? Just include it as a part of the final answer. Okay? And in fact, for this answer, if you want to make it shorter, you can do it, okay? Notice that this value in here is like pi away from this value because the period for tangent is pi, right? So instead of going for the whole circles, we can actually go for half of a circle. So I'm gonna pick on the smaller family, and I'm gonna do k pi. Okay, pi in here for like half of a circle. K in here for like how many halves of the circle that you want to. You can go for like 1/2. You can go for like 2/2 of the circle, and so on. Okay. So this in here could be the final answer if you want, or if you want to simplify it further, you can go for this. Okay. Either way, I'm gonna like mark you as right. Okay. I'm not gonna mark you off. Okay. And now let me take some of the workout so that we have space for, you know, the second part. Okay, let me put it in pink so that you don't get like confused. So now the problem is asking us to solve for the following equation on the interval from 0 to 2 pi. Okay, so I told you guys from before, if we have this restriction in here, that means that we have to be that means that your angle has to be something that is, you know, within 0 to 2 pi, right? It cannot pass 360, and it cannot be less than 0 in the sense that it cannot be like negative, and it cannot be bigger than 360, okay? So to do it, we're going to do the same procedure as before. We're going to solve for the trig function first, but since it's also already isolated, we're going to jump directly to the unit circle in there. Cosine value is on the x-axis, right? So we're talking about the x value that has the value of negative square root of 3 over 2, which is right here. Okay. If you don't trust me, input negative square root of 3 over 2 into your calculator, and then you're going to get something like negative 0.086, something like that, which is like really close to 1, right? So you know that it has to be like right there because negative 1 is right here and 0 is right here already. It cannot be like a half anymore in this time. It has to be like closer to 1, okay? And if you project it up and down, you're going to get 2 points right here and here. These are actually the two families that you're having. So let's work for the last time. Last time, you only get like one family, and then you have to do, like across the origin to get the outer angle. This time, it's just like there. Okay, so this one is pretty good. Okay, and if you want to test on like what I taught you guys on the last page, notice that this point right here and this point here, they like symmetric by the x-axis, right? And again, x-axis represent for like cosine axis, so that makes sense, right? Why they like symmetric toward the x-axis. Okay, and as for like to find the angle in here, okay, how do we do that? First of all, this is not like a best circle in here, so let me redraw it so then it will make more sense why it's like, like the angle like that. Okay, so first of all, let me just, like put it more like this. So you guys can see that it's like right there. Okay. Well, it's not better. You know what? Here, let me make like a better circle. How about that? And you guys will understand like the importance of drawing like a good circle in here. It helps a lot. Okay, and negative 0.08 is like right here. So you're gonna have two angles, one from here and one from here. Okay, this one is not drawn to scale, of course, because I'm not like an artist in drawing circles, and I apologize ahead of time for that. Okay, but all right. So how do we know the angle, right? So we're gonna do the same as before. This is 90. We all know that. This is big enough, so I would assume that this is 60. Okay. And again, if you don't want to use this method, you can actually go for the unit circle in there, and in the like in this position, this position where you have the x part equals to negative square root of 3/2. You can figure out the two angles right away. Okay. But if you don't want to carry the unit circle with you, you can definitely do my thing. Okay. So anyways, we have like a 90 in here and a 60 over there. So together we add them up and we have like a 150 in here. Okay. And same thing in here, the leftover part in here would be, like 30 and another 30 in here. So it's like 60, 150 plus 60. I'm having 210 in here. Okay. And if you don't want to, remember, you can always do like, like half of the circle, which is 180. And then another 30, which is 210. Okay. So either way will work. And after that, you're going to convert them back to radians. So 115 is what? 5 pi over 6. And the other one, 210, it is 7 pi over 6. And this is really important, so make sure the very next thing that you do after figure out the angles is to convert them back to radians, okay? So we have this angle in here and this angle in there, right? All right. Now let's get to work. So unlike the last example where we just have like theta inside, we have like a chunk of things in here, right? And we're gonna grab that chunk of thing. We set it equals to the two families that we have in here, which is 5 pi over 6 and then plus 2k pi, because I told you guys can go for like more circles in there. That is one case. And then we have the other case with 7 pi over 6, right? So we're gonna do the same thing in here. But instead of having the 5, we're going to have the 7 pi over 6 in here. And again, we're going to do plus 2k pi. Okay? And in each case, we're going to solve for theta, okay? So fast forward, I'm going to add both sides by pi over 2. So that gives me 2 pi in here. And then I'm going to use my calculator. Sorry for the noise. Okay. Quick trick in here. If you're not familiar with the calculator, don't put the pi in there, okay? So I'm going to do 5 over 6 plus 1 over 2 on my calculator. And that gives me 4 over 3, right? And what I'm going to do is that I'm going to put the pi back to the 4, okay? But I actually like don't put the pi on the calculator because the calculator will not take it easily, okay? So just like leave the pi out and then input the numbers in the calculator. And then at the end, return the pi back in, okay? And now we have like 2k pi in here because we don't do anything to the 2k pi. And then we divide everything by 2. So then this is 2 pi over 3 and this is k pi. Okay? And we're going to do the same procedure for this one. So I'm going to fast forward and give you guys the answer of this one, which is 5 pi over 6. plus k pi. And remember, in two cases in here, in both cases, k in here is actually just an integer, right? So it can be, you know, like 1, 2, 3, so 4, 5, and so on. Or it can also be 0, it can be -1, -2, and so on, right? So now we have to plug in the k values to make sure that the angle in here has to be within 0 to 2 pi, okay? So what we're gonna do is, okay, let me separate it out because that's like part 1, part 2. Okay, let's plug k in for 0. So if k is 0, you're gonna get theta equals to 2 pi over 3, right? Okay, if k is 1, what do you get? We're gonna get 2 pi over 3 plus 1k, right? And like I said before, in the calculator, you're gonna put 2 over 3 plus 1, okay? And that gives us 5 pi over 3 because you put like the the pi back. So theta in here equals to 5 pi over 3. Okay? And okay, let me get this one out of the way so that I have more space. Okay, and similarly, if you plug in k equals to 2, you're gonna get theta equals to, let's see, 2 over 3 plus 2, that is 8 over 3 pi. But wait, 8 pi over 3 though, 8 pi over 3, if you convert it into, you know, like degrees, what do you get? A divided by 3 times 180, that is 480, right? There's something wrong with this one, right? Like 480 is way too big for this restriction in here. We only need something within 360. So 480 is not within 360. That means we're not gonna even like consider like the case of k being equal to 2. And that means we're gonna eliminate all the other case after 2. We don't have to plug in k for like 3, 4, 5, and 6 and so on because it already passes one circle, right? So that means that right here, right now, we only have 2 answers. This one in here and that one in there, okay? Now, let's talk about the outer family. We're gonna do the same procedure. So for k equal to 0, we get theta equals to 5 pi over 6. That's one of them. And for k equals to 1, what do we get? We're gonna get, okay, let me put into my calculator, 5 over 6 plus 1, which is 11 pi over 6. And if we plug in k equals to 2, what do we get? 5 pi over 6 plus 2. That is 17 pi over 6. But wait, if you convert 17 pi over 6 to degrees, that is 510. And 510 is like way too big for this restriction again, right? Because it's bigger than 360, right? So we're gonna disregard the case of k being 2 and then all the case after 2, right? So that means that we have 2 more answers. This one is a good answer and this one is also a good answer because all 4 of them are inside a unit circle, right? Like they all within 360, right? So that means for this question, for my part B, I end up having 4 answers in, you know, like in green highlight there, okay? And that is like all the work for this one. And I know it's hard. I admit it's really hard. That means that you have to practice this a lot just to make sure you can have enough time in the quiz and in the test, okay? So don't wait until the last moment to like practice this because it's hard. And this is your part. You have to do like part A and you also have to do part B, okay? Moving on. Solve trig equations using a calculator. So again, like whichever one that has like calculator involved, I'm not going to test you on this one because it's not our work anymore, it's the calculator work. So just like before, I advise you guys whenever you have like secant, cosecant, or you know, cotangent, we're gonna like use the reciprocal of them or like the flip of them. So let me go over some like concept first. Since we're solving for the angle, which is the output of the inverse trig functions, recall how to type the inverse function into the calculator, okay? And again, like make sure your calculator must be in radian mode, okay? If you don't have it in radian mode, make sure you know how to have it in radian mode, okay? And then recall the 3 reciprocal identities in here. They're really useful. The calculator only gives one branch of the angle, which is usually in question 1 because it's positive. But there might be more than one answer, right? So we have to like stick with the pictures, the 4 circles that I draw earlier on page, I remember like page 2 or something like that, to figure out the outer angle, okay? Because we usually have like 2 family angle, right? Yeah, so make sure you use the geometry to figure out the outer branch of the angle, and then we good from there, we cool from there, okay? So for my part, let's do it down really quick. I have like 2 parts in here. Let's talk about part A, where I have the secant in here. And I told you guys I'm not really good with secant, so I'm gonna flip it back into cosine because they're flipped with each other. And I'm gonna flip the value also, right? So I'm having that, right? So what I'm gonna do is that I'm gonna use the calculator to calculate for my theta by using the inverse function. Okay, like this. I'm swapping inside out, and again the compromise for it would be the inverse notation, okay? And if you put this one into your calculator, if you do it correctly by having everything in, you know, the degree mode, give me 1 second. Okay, let me just set it up to radian. Okay, so I'm gonna do cosine inverse of -1 divided by 4, and that gives me 1.82. If you guys like want to route out. And I told you guys this one is only like one angle, right? Like we also have like the outer family as well. So I'm gonna draw it out first. 1.82 radian. To me, okay, how can we convert it back to, you know, like degrees, right? So we know that 2 pi radian equals to, no, pi radian equals to 180. So then 1.82 radian equals to what? So we're going to do 1.82 times 180 divided by pi, which is 3.14. And that gives me something like 104 degrees, something like that if I round off. And 104 is a little bit like passing the 90, right? So I'm going to say that it's right here. Okay? And because we're dealing with like cosine here, right? So what I'm going to do is that I'm going to project it down toward the x-axis, and my other angle is this one, okay? So from geometry, I know that this arc in here is 104, okay? So then I'm gonna use 180 minus 104 to get my pink arc, which is the leftover in here. Okay, so 180 minus 104, I got 76. And geometry again, this arc in here is also 76. So I'm gonna add everything together. So I got 104 plus 76 plus another 76. And the outer side in here, I'm gonna get 256 degrees. And again, after I get the angle, I have to convert it back to radian. So here, let's set up like a like the math in here real quick for the 256, right? So we have like 256 in here this time. So what would be its angle in radian? I'm gonna do 256 times 3.14 divided by 180, and that gives me something like 4.46 or like 4.47 if you want to route it. 4.47 radian. Okay, so the 2 families in here, the final answers in here, let me write in here. Theta equals to 1.82 plus 2k pi and 4.47 plus 2k pi. This is it. Okay. Similarly, we're gonna do the same thing for the second one. First of all, we're gonna solve for tangent, and I'm gonna like fast forward. First of all, we minus both sides by 2, and then after that, we're gonna divide it by 5. Okay. So I'm gonna do -4 minus 2 on a calculator, which gives me -6. I divide it by 5, and it's a fraction, -6 divided by 5. Okay, and I'm gonna swap them to figure out theta. So theta in here equals to tangent inverse of -6 divided by 5. And to the calculator, make sure your calculator is in radian mode. It is -0.88. Okay, first of all, you know what? Let me get rid of this before it confuses you guys. Wrong. function again. Okay, there we go. So now, again, we only have like one angle, right? So we have to figure out the other angle, and how can we do that? Well, we're gonna use the unit circle method, okay? So we draw a unit circle in there, and this in here, if you want to like convert it back to like degrees, we have to set it up the, you know, like the 180 equals to like pi in here. So then for negative 0.88, no, ground column, the radian column, how much is it in degrees, right? So that's the setup, and we're gonna do negative 0.88 times 180 divided by 3.14, okay? So let me see what it gives us. That is negative 50 if you like round off. And negative 50 is like right here-ish. It's like bigger than negative 45 a little bit, so it's right here. And because we dealing with like tangent in here, right? So we're gonna go across to, you know, the origin, and then we get to the outer side of the unit circle. And because this in here is like negative 50, so by geometry, how much is like this in like the outer angle, right? So to do that, what do? We're gonna like use the idea that the period for tangent is pi, and pi is 180, and we're gonna do 180 minus 50, which is 130, right? So the other side has to be 130 degrees. Okay? If you don't like that idea, you can think of them like this. You can think of it like, you know, this in here is like 90, and this in here would be, you know, equals to this part, and this part is like, what is it, 40? So 90 plus 40, you have 130. Okay, so either way, to get like the outer angle would be fine. You just have to use geometry in here, okay? It's really hard to use, like, to explain the geometry in here, but it all makes sense if you have like a good circle to look at, okay? So we have like two angles in here, this and that. We already get that down. This is like negative 0.88, right? But what is this one in terms of, you know, like radian, right? So let me do a setup really quick for the other one. So 130 degrees, we have it right here in the degree column. So I'm gonna do 130 times 3.14 divided by 180, okay? And that gives me something like 2.27, okay? And now, as for the final answer, again, we're gonna have two family again. Let's sort them from like, you know, from least to greatest. So usually I'm gonna go with this one first and then this one second. But I told you guys from before, I don't really like the negative angle at all. So instead of having it in like negative angle, I'm gonna convert back to, you know, like radian. And we know that one circle is like 360. That means 2 pi. And 2 pi, if you put it into the calculator, 2 pi is 2 times 314, right? And 2 pi in there would be like 6.28, okay? And if I subtract it with 0.88, this angle in here, in the positive version, it is, what is it? 5.41, okay? Like the 1 inches, no, 5.40, how about that? 5.40, this one in here, okay? So instead of using like the negative angle, I'm gonna go with like the positive angle instead. And this one is from the outer family, so I'm gonna have them both in there, and I'm gonna arrange them from least to greatest. And what is it? We're gonna have it as 2.27 plus 2k pi, and the other one as 5.40 plus 2k pi. And earlier I forgot to mention with you, like for the other problem, it's not stopping at here, because I just like looked back at the problem and it's asking us to do something within like 360, right? So that means in here the values that we have, the angles that we have, it must be within 2.28, okay? It cannot exceed 2.28, okay? And if you plug in the k values, just like what we did before, the only k value that would work in here for like both of the question, part A and part B, would be k equals to 1 for, you know, for this case or for the other case. part A, and for this case or for the other case. Okay, the only thing that you can get is just k equals to 0, because if you plug in k equals to 1 or 2 or anything else, that will exceed like 6.28. Okay, so the final answer in here would be just theta equals to 2.27 and 5.40. Okay, so let me box it to make it official in here. Okay, so let me put a green star on your part before I move on. And number 3. Okay, that looks shorter. Oh, by the way, there's like a footer right on the last page. When it comes to use a calculator, this in here means to tell you that we're gonna have tangent inverse. We're not gonna just ignore the the theta in here and treat it like air, and just like do the value right away. This is not right. So make sure you know how to use your calculator correctly. Okay. And of course, I'm not going to test you on this one, but like just in case you have like something that has to do with this in a future job or whatever, be careful with this, okay? Especially on the homework, you have to know how to use your calculator, okay? So now, objective 3, solve trig equations quadratic in form, okay? So first reminder, recall when we solve a quadratic equation. For example, if you like have something like this, how do you do it, right? Then we can apply quadratic formula or use factoring method, including the grouping method, X method, and diamond, and so on, right? In the exam, you will see the grouping method, okay? So watch out for that. That's something that you have to be careful for. And the worksheet and in the quizzes, you're gonna have the X method or the diamond method if you referred. And some people, I think they call it the box method. So if you Google the name, I'm pretty sure you can see it up on YouTube and Google a lot. It just tells you that technically, like, you're gonna have like an x-axis like back in the day, and then the -3 in here, the middle number, it will go into the bottom. Usually the back number in here will go into the top part in there, but because we have a front number in here, so we have to multiply the front and the back number together and put that number, whatever we have, onto the top part. Okay, so that's like the AC method if you want to look it up. Alright, so our job is to find two numbers that multiply to 2, but then at the same time add to -3, okay? So I'm thinking of -2 and -1, because -2 times -1 is 2, and -2 plus -1 is -3, okay? So from here, my next step would be x minus 2, because we have a -2. That's for one of them. And then the other one would be x minus 1, because we have a -1 in here. And then we set it equal to 0. And then we set each of them equal to 0. And then we solve for x, comma in between, I guess. And then we're going to get x equal to 2 for the first case, and then x equal to 1 for the second case. Okay? Like, this is like way back in algebra, okay? So I'm not going to spend too much time to talk about this one, but watch out for this one. It's going to show up in the quizzes and exams, okay? In different forms, and I'm going to show you guys what it means by in the next second. Okay, so let's talk about the first example that we have in here, right? Let's see. Okay, so this 2 in here, it's not a square, just so you know. This 2 in here is just, like what is it, the footer in here, okay? So just in case it confuses you guys, let me rewrite the problem properly. So it is cos square of theta plus 8 equals to 9 cosine of theta. This is the problem by itself, okay? And I noticed that the cosine here repeats more than one time, so I'm going to let cosine of theta equals to x. And next time I'm going to get something like, I don't know, like x squared plus 8 equals to 9x. Okay, and I'm gonna arrange everything together on one side and leaving the other side 0. So I'm getting x squared minus 9x plus 8 equal to 0. And in here I'm gonna do the x method again. I'm gonna put the middle number onto the bottom. The last number multiplied with the front number is 8. And notice in here the front number, we don't have it. Okay, it's invisible. It's an invisible 1. And 1 times 8 is 8. That's why on the top part we just have 8 in here. Okay. And again, we have to find two numbers that multiply to 8, but at the same time add to -9, right? I'm thinking -1 and -8. Okay, so just like before, we're going to have a setup. And we're gonna have like x minus 1 in here, x minus 8 in here, equal to 0, and then we solve for each of them, we get x equal to 1 and 8. But this is not the end, okay? So don't call it the end. Don't call it the answer, okay? Notice from the beginning, x equals to like cosine of theta, right? So what we have actually in here is cosine of theta equals to 1 and 8. Okay, so let me break it into two cases for you guys. Here, let me just remove all this out. Okay, so 1 in here is the first case. Second case, we're going to get cosine of theta equals to 8. Okay? So now, if you look, if you use a calculator, you're going to get like this one, theta equals to cosine inverse of 1, which is 0, or what is it? What does it show you actually? Cosine inverse of 1, this is like 0, right? And I told you guys they're always like two family, right? So here, let me draw a unit circle on this one again. So we know that the first one is 0, right? So we have to look across from the x-axis. But if you notice, the 0 angle is right on the x-axis, right? So the outer family is actually itself, okay? So in this case, we only have one angle. It's duplicated, it's like two angles, but they all are like 0, because 0 is 0 if you look across from, you know, like the x-axis. So you're gonna get like 0 plus 2k pi in here. And because the problem asking us to go within like one circle, so we're gonna plug in values for k again. We get k equal to 0, then the theta would be 0. If k equals to 1, then the theta would be 2 pi, but unfortunately we don't take the 2 pi in here, right? There's no dash like close to the 2 pi in here. That means we don't accept the 2 pi, okay? So that means we're not gonna even like plug in 1 for k, because that's not worth it, okay? So we have like one answer so far for this family, right? For the other case, if you input cosine inverse of 8 in there to figure out like what value of theta is, soon you will realize that it shows you an arrow. And that is because if you look among the unit circle, everything in here is covered by 1 and negative 1, right? So you have an 8 in here for cosine value. That is impossible, right? And if you link back to the like the main and range that we learned from chapter 7, cosine value, it has to be something between negative 1 and 1. Again, 8 is way bigger than 1, right? So this is like not a good value. And in the second case, we're not going to get anything, okay? So the final answer, like the final answer for the example 3 in my part, it is theta equals to 0. And that's the only solution that we have. Okay? And again, let me put a green star for your part. Okay, moving on to the very last objective of the day, because 5 is optional. Okay, solve trig equation using fundamental identities. Okay, just a heads up, it's going to be like a little bit hard, but we can pull through this. We can do this, okay? So bear with me. Okay, just a little bit like reminder about like all the things that we had in the past. We have Pythagorean theorem, these three, and we also have the reciprocal identities, and we also have the quotient identities, okay? Like all the important identities that we learned from chapter 7, okay? And quadratic formula, we just have like a flavor of it. We can use the X method when it comes to like, you know, like using X for substitution if you have like a function that repeats by itself more than once, okay? And to make it simple, again, we can think of U substitution like what I did in here by using X in here. So here, let me just highlight that. I use X in here to make it easier, right? So I don't have to carry the cosine to like the end of the problem. And that is really helpful too, at least for some people, okay? And just to keep it like formal, because we're doing like math, I would like to keep the answer from, you know, like from least to greatest. But if you don't, I'm not going to mark you off, okay? So now, let's get to work. Solve the following equations. And notice that we have to be within one circle, right? We cannot go exceed one circle, okay? And just a heads up, it's going to be on the exam 1, okay? And it's also going to show up on the final and quiz 3, I believe. But I could be wrong about quiz 3. I don't remember what I put on quiz 3 anymore. But I'm pretty sure that this will be on the exam 1, okay? So keep in mind that. Alright, so what are we going to do with this? Well, we have cosecant, we have cotangent in here. Clearly, they are two different functions, so we have to find a way to put them into just one function, right? And if you look on the squares that we have in here for the Pythagorean theorems, the only one that connects cotangent and cosecant is this one right here, right? So we know that cosecant in here, it equals to cotangent squared plus 1. So I'm going to go ahead and replace this by cotangent squared of theta plus 1. And on the other side, I'm going to rewrite them as cotangent theta plus 1 because that's what we have from like the problem on the right hand side. Next step, I'm going to try to simplify them. So I'm going to go ahead and minus 1 from both sides. That means I'm going to lose this one and that one also. And I ended up having like just cotangent squared of theta minus cotangent theta, right? Because I'm trying to make a 0 in here so that I can use the x method, right? In here, if you want to use the x method, you can do that. You can treat the last like term in here like a 0. Just imagine you're gonna have like a 0 in here. If you want, you can think of it like x squared minus x plus 0, right? And then in this case, x represents cotangent theta just like before. The bottom number would be 0, and then the middle number, the -1, would be the top number, okay? And then you keep going from there. However, there's actually an easier way than that, so I'm not going to do it in this way. I'm going to do something else. My easier way to do this is I can factor out a cotangent of theta, okay? For the first term, I have cotangent squared. That means that when I take out one cotangent, I'm going to have like one cotangent in here, okay? For the second term, since I only have like one cotangent, when I put it out, I have nothing left instead of like, you know, a 1, because 1 times cotangent, -1 times cotangent equals to negative cotangent in here, okay? So make sure when you factor it out, you'll put it a 1 in here, not a 0, okay? Because 0, it means like you make the term disappear completely, and that's not right, okay? And now on the right side, I'm going to get like a 0 in here. So let me take that out. And then next, what do? I'm going to set each of them equal to 0. So first one, I'm going to get cotangent equal to 0. And the second one, I'm going to get cotangent equals to 1. Okay? Because I'm going to like add both sides by 1, right? And then that's how the -1 got canceled. And then the 1 appears on the other side. And then just like before, because I'm not familiar with like cosine, so I'm going to flip them. So in this case, I'm going to get tangent of theta equals to 1 divided by 0. And we have a 0 on the bottom, which is bad, right? So that means that for the first case, we're not going to have any solution. Theta doesn't exist. Okay, so that means that you can just ignore it. You still have to show the work on the test and in the final. And then you're going to tell me that theta doesn't exist, okay? I just cross it out so that like it doesn't distract you from the work, but you have to show the full work on the exams, okay? And for the second case, when cotangent equals to 1, first of all, I'm going to flip them. So same thing, I'm going to get cotangent equals to 1 divided by 1, which is 1. And from here, what is it? If you remember from the table that I mentioned with you guys on like every lecture now and then, like 30, 45, and 60, and then sine, cosine, and tangent, right? The only place where you see tangent equals to 1 is in here, underneath of the 45, right? So the first function in here, the first angle in here would be pi over 4 plus 2k pi. And then we also have the other angle as well, right? Because of course it has to have like 2 family, right? So let me put that circle in pink. Okay, unit circle. And then the first one is 45, so it's right here. For tangent, we're going to look across to the origin, so we're having this right here. If this one is 45, we're going to add it to 180 because we look like half a circle across the circle. So 180 plus 45, we have 225 in there, okay? And if you convert this to, you know, the radians, then we're going to get something like, what is it? Okay, hold up. 1, 2, 3, 4, 5. 5 pi over 4. Okay, I have my trick for this one. If you want, you can ask me for it. It's like a best way to convert it to convert it. But if you lazy, you can use a unit circle to figure out like the angle in radian, or you can just like do the conversion like what we learned in chapter 7. Okay, so I have two families in here, right? So then let me put it down here as a second family. Okay, I don't think I can write anymore in here, but just imagine you saw the pi in there. Okay, this one. Okay, you know what, here, let me just rewrite its name. So 5 pi over 4 plus 2k pi. Okay, and in either way we have to plug in k values, right? So in here we're gonna plug in k equals to 0 and k equals to 1, blah blah blah. Fast forward, you're gonna get theta equals to pi over 4, also 5 pi over 4, because if you go for more, you're not gonna get an answer. Okay, so these like partially, these are the part of the answers. Okay, I make an arrow earlier, so here let me just fix it before it get into you guys. So for this case, let me put it in green to catch your attention again. So in here, just because like when we flip it, it has like a 0 on the bottom, and the theta, it doesn't exist, right? But like it has nothing with our original problem, right? So instead of like doing tangent in here, it doesn't show us anything. Let's take that away, okay? Because this idea, this approach, it doesn't give us any value for theta. So instead of doing that, we're gonna use the quotient identities for cotangent, which tells us that cotangent equals to cosine divided by sine, right? And on the right hand side we got a 0 in here. And notice that 0, it equals to like 0 divided by whatever would give you a 0, right? So that means that like as long as the top part is 0, the side part, the bottom part, it doesn't matter what it is anymore, right? It can be like 1, 2, 3, 4, 5, whatever you want it to be, because 0 divided by anything would be 0, right? So that means that we're gonna have cosine of theta equal to 0 in here. Okay, and because 0, -1, and 1, they refer to the quadrantal angles. So if you want, you can draw like a picture of your quadrantal angle in here, and then you go like label all the points in here really quick. So this one is like 1, 0, and then this one is like -1 and 0, and so on for the other ones, right? Cosine here is the x part, right? So I have to keep labeling the other one. 0, -1. Okay, cosine here is for the x part. So there are two places that my x part equals 0, right? Which is like right here and right here, which mean I have the angle of 90 and 270. Okay, within one circle they are just that, right? So you don't have to keep going for like more circles. So for the first case, we actually have two more answers, and they are pi over 2 for the 90 degrees, and then 3 pi over 2 for the 270. Okay, so all these are the final answers. Okay, so let me just make it official by putting it in, I don't know, like blue. So theta in here, it equals to pi over 4, because I have to arrange them. Pi over 2 in here first because it's 90, and then 5 pi over 4 because it's bigger than 90, and then lastly 3 pi over 2. These are all the answers that I have for just one problem, and this is your part. Good luck. I mean, it's hard. I know it's hard. It's like two hard problems on the same worksheet, but yeah, you have like a week to do this one, so yeah, please spend some time on this one. Okay, last part is optional. It's like graphing utility, so you can use like graphing calculator or like Desmos, GeoGebra to deal with this one. I'm not gonna explain this. I'm not gonna talk too much about this one, but if you want, you can ask me questions for this one. Okay, like if you want to learn about it, I'm willing to share. I'm willing to teach you. Okay, but again, I'm not gonna test you on this one, and you guys don't have to do this problem to turn it to me. Okay, that's why I'm not gonna put any like green stars in here. And to recap what we learned for today, I put like a summary in here. Today we learned to solve the trig functions in 3 methods, right? We can use the graphing of them, just like what we did in the first page, like drawing the graph of cosine, and then in there draw like a horizontal line of the value that the problem gives us, and from there get the two family, right? Like two angle families. The second way, the unit circle, the one that I show you, is like like the tips with tangent, sine, and cosine. And then the last part, we're not gonna even talk about it, and I'm not gonna allow for you guys to use this technique in the quizzes or exam. It's like this one in here, where you have like the graphing utility in there, okay? But again, make sure in the quizzes and on the test, you guys have to show the work, right? So if you guys cheat and use like the graphing utility to get the answers, you're gonna get the 0 for the test, okay? So keep in mind for that. And I know this one is a hard worksheet, so if you have any questions, please contact me, please talk to me, please get a Zoom meeting with me like right away before we have exam 1, okay? Thank you for your listening. Take care and have a great day. Bye-bye.